Welcome to Bio 3 again. Today we'll talk about protein. Remember the last few lectures we already talked about carbohydrate and lipid is a very long lecture. So today we'll talk about protein, which will be relatively short lecture, so good for you. Protein contains carbon, hydrogen, oxygen, and nitrogen, and sometimes it contains sulfur as well. And remember, carbon, hydrogen, oxygen, and nitrogen, these four are the most abundant elements in our body. Synthesized from a long chain of amino acids which are linked together in a precise sequence. So the polymer is protein, the monomer will be amino acid. The monomer is the amino acid. We'll look at the structure of amino acid very soon. So polymer of amino acid, we call that protein. And in our body, we need 20 amino acids. 20 is the magic number I want you to memorize. 20 amino acid is like a common sense, so everyone needs to know this. The structure of amino acid is very simple. So remember, it has a center carbon. We call it an alpha carbon. As hopefully you remember at the beginning of the semester, we learned about the covalent bond of carbon. How many covalent bond a carbon can have? The answer is 4. So you can have 1, 2, 3, and 4. 4 covalent bond. So one covalent bond will be formed with hydrogen atom, with one hydrogen atom. Another one will form with an R group. We call it functional group or side chain. Well, usually I call it functional group. Functional group, R group, and then we call it amino acid because main reason it has an amino group. Amino group, as you can see, is one nitrogen atom attached to 2 hydrogen atom. So it's an NH2. We call this amino group. And then we have a carboxylic acid group. It has a different name. Some textbooks call it carboxyl group. So carboxyl group, it is a one carbon atom formed with a CC double bond O, and then formed with a OH hydroxyl group. We usually just call it COOH. Why do we call it carboxylic acid? Well, if you remember our previous lecture, acid, what is the property of acid? It can ionize or dissociate hydrogen atom. And this is the hydrogen atom that carboxylic acid group can dissociate or ionize, so that it will become a hydrogen ion, H plus. And then the COO group will have a negative charge associated with it. So you have a negative charge here after the hydrogen is ionized. That's why we call it amino acid, because it has one amino group and one carboxylic acid group. In other words, amino acid is acidic because it can dissociate a hydrogen ion. Now, next few slides, they are just repeating what I just told you. Amino group, okay, NH2, and then this is the NH2, and then carboxylic acid group, or they just simplify as an acidic group, which is here, COOH. And our group or functional group is the side chain. And as you can see in here, the OH and the H, we add them together. What do we call this? What do we call this process? When we join two amino acids together and removing one molecule, we remove a OH, the other molecule, we remove a hydrogen atom. So what do we call this process? By joining two amino acids together and removing one OH and one H? Well, do you remember? The answer is dehydration process. Yes, this is the dehydration, because you are removing a water by connecting two monomers or two amino acid group together. Dehydration. Okay, dehydration. So this is an example of dehydration. Okay, the functional group, the R group. There are some R group that is listed here. For example, if it is CH3, then it will be alanine. If it is branch chain, then it will be a valine. If you have a SH group, CH2 attached to a SH group, it is a cysteine. If it has a CH2 and a benzene ring, remember benzene ring, we talked about it previously, it will be phenylalanine. So with different functional group or with different R group, we can have different amino acid. The question to you is that how many different types of R group our body require? How many different types of R group you can find in our body? Or this is another question. How many different types of R group we can find in our bodies? Let me give you a few seconds to think about this. Okay, the correct answer is 20. Why? Because our body requires 20 amino acids. Therefore, you can find 20 different functional groups in our body. So here are the 20 amino acids you can find in our body. As you can see, let me see. Well, as you can see, they all have different R group or functional group. For example, tryptophan looks like this. Is a ring, hexagonal ring attached to a pentagonal ring with a nitrogen there and then CH2. This is phenylalanine we saw before, but if we attach a hydroxyl group onto the side chain of phenylalanine, we call it a tyrosine. Tyrosine is important because tyrosine is the precursor. Precursor meaning that is the first precursor meaning that we make other things based on this. Tyrosine is the precursor for something called dopamine, which is a neurotransmitter that makes you happy, and dopamine is the precursor for epinephrine and norepinephrine. In other words, we need amino acid tyrosine to make our adrenaline. Norepinephrine and epinephrine, they are adrenaline, so we need to have tyrosine in order to make adrenaline. In other words, tyrosine is a precursor for our adrenaline. As you can see, the different side chain give you different amino acid. But for all 20 amino acids, they have the same basic structure. Let me remind you what are the basic structure. You have a center carbon, they call it alpha carbon. You have a hydrogen atom. You have a carboxylic acid group here. You have an amino group here. Last but not least, you have a functional group here, R group. So all amino acid has a similar structure. The only difference is that they are functional group, the R group. And then 9 amino acids, they are called essential. You also need to memorize the magic number 9. Yes, 9 essential amino acid. That means we cannot make these 9 amino acids by our body. We cannot make these 9 amino acids by our body. For example, histidine, isoleucine, all these. Methionine is the start codon, start amino acid. When you do translation, tryptophan, valine, all this, we cannot make it by our body. What does it mean? Meaning that the only way we can have this 9 amino acid is by feeding, by acquiring them from food. So the only way we can acquire them is from food, and that's why we need to eat a balanced diet. Non-essential doesn't mean that they are unimportant. Non-essential meaning that our body can make them from other nutrients. Oh, by the way, I do not require you to memorize the 9 essential amino acids. As a matter of fact, I do not require you to memorize the 20 amino acids. If in the future you study biochemistry, if you take upper division biochemistry, well, by that time you will need to memorize the 20 amino acids, and you will also need to memorize the 9 essential amino acids and the 11 non-essential amino acids. And as a matter of fact, if you study biochemistry, you also need to memorize the structure of all 20 amino acids, the functional group. But since this is just a bio thread, introduction to biology, and it is for non-major people to take it for satisfying their GE requirement. That's why I do not require you to memorize all this. You just need to memorize 9, the magic number 9. So in order to have a complete diet, you need to acquire the 9 amino acids. Where can you get what kind of food you can get complete protein? Like eggs, meat, fish and milk. So for vegetarian, if you don't eat meat, then you have to be very careful. Why? It is easy to get incomplete protein. So some of you may have heard about this. For Asian diet, we like to eat rice and tofu. Why? Because coincidentally, when we eat rice and tofu from soy product, tofu is a soy product. If we eat rice and tofu, we will get complete amino acid. That means we can get all 20 amino acid, or at least 9 essential amino acid. And for Hispanic diet, if you eat corn and bean together, then you also get a complete diet. I forgot, either corn or bean or flour is the traditional staple Hispanic food, corn and bean, something like that. Then you get complete amino acid or complete protein. Okay, peptide. What is peptide?